So I'd like to show you how to use Vernier Logger Pro software to collect data for another type of lab experiment. In this case, I'm going to use video to collect 1D motion data and show you how to use Logger Pro to pull in that video and collect the data from it. I'll start by defining what slow-mo video is for you if you don't know. And then I'll show you how to set up Logger Pro's software to collect the data from the video. And then finally, I'll show you how to use their analytical tools to make some heads and tails of the data, and so you can discuss it in your lab write-ups. So let me play in the background here a little video from YouTube by the slow-mo guys, and they're trying to bust this really big water balloon, but they're having some problems. So you can have fun watching that in the background here. So what actually happens when you take a video? Well, essentially you're taking a whole bunch of pictures evenly spaced in time and then playing back to the user. And the rate at which we take those video pictures typically is 30 frames per second on a standard camera that you would have to take video from. So slow-mo video, ironically, is actually high-speed video. Instead of recording at 30 frames per second, you're recording at a much higher rate. On a typical cell phone, you might be recording at 120 frames per second. iPhones, Apples actually record at 240 frames per second for the iPhone 5, 6, and 7 and beyond. And as time goes on, they might get faster than that. And you can buy much more expensive cameras, like the slow-mo guys are using probably a $10,000 camera to do what they're doing over here, which may record at 30,000 frames per second. Afterwards, when you play back the video, if you play it back at 30 frames per second, you have the appearance of slowing the motion down. So for example, if we were to record at 120 frames per second and play it back at 30 frames per second, the motion will appear to be going at a quarter of its normal speed. And you'll want to look up at your camera what it is recording at. Like I said, standard videos at 30 frames per second, but the videos that we see now in good cameras now on your cell phones run at 240 frames per second. Now, one thing to be aware of, as you're taking these pictures at a faster and faster speed, you have to open and close the aperture to let in light for a shorter and shorter amount of time. And so as a result, well, there's an upside to that, is that if an object's moving quickly and you're only looking at it for an instant in time, a small instant in time, that there's less blurring of the object. So the downside to this very fast photograph that you're taking is that you're going to need better lighting. So make sure you're in a very bright situation outside, for example in daylight, or have some additional lighting inside to get a bright picture. Once again, this is because the shutter is open for such a small time that we're actually capturing less light per frame, so we have to force more light through that aperture. So as you've seen, these guys have been having some problems, so what they decided to do is to have two people jump on it, and it pops. And that's played at regular mo, and now they'll play the slow-mo. Now, like I said, this is a very expensive camera they're using, and they're probably recording it at, I don't know, 2,500 frames per second, or maybe 25,000 or 30,000 frames per second, and you're getting a slow-mo rate of about 100 times the normal rate you're slowing this down. Fun videos these guys make. So here's the steps we're going to take to do the Logger Pro video analysis. First, we need to set up the video. And what we're going to do is first make sure you don't have any other sensors plugged into your system. If you did have, for example, the sonar sensor plugged in and you started up the system, you'd get sonar data ready to go up here, and on top of that you'd try to put your video data and it would get messy. So just make sure your other sensors are unplugged. Secondly, use the insert movie option, and then you're going to resize the movie to fit the screen. And you'll end up with something that looks like this. But let me show you how that's done. So here we are. I'm going to insert movie, and then I'll find out where it is. I already have this in a recent folder. I'll just double click on the video. Also, notice how I name my videos. You should have a very descriptive name. You would have your name on it, what you're doing, and also you should tell what frame rate your video is taken at. The other thing that you should always mention is how high your camera is set, and this camera is set to the middle of my range of the ball, and how far back you are from your position. And in this video I'm 2 meters back, and that's probably something I should have put in my title for this. And so I'm just going to resize this to fit as big a piece of the screen as I can, and I'm ready to go. Alright, so let's see what our next step is. So now what you can do is you can use the controls for the video, and you can actually play the video and move it up to the point where you can start seeing the object having the motion you want. In this case, I'm going to have a yellow ball flying out of this device. It's going to move up to, I don't know, about this high, then it'll come back down in. So I just want to find out where the first point is. And I can also use this pair of tools here. This moves the video frame by frame. Up top over here, you'll see what frame I'm on. In the video picture that I snapped to here, I'm on frame 0, so I'm on the very first frame of my video. And you can watch what frame to see what you're on as you do this. So let me show you how you do that. So I'll just play the video first, and I can use the slide tool here, or I can use the play video. And this is recording at 120 frames per second. This is on my Android phone. It's a Moto G5 Plus. Doesn't have as good resolution, and it's not as high a frame rate as a iPhone have. iPhones do have great cameras on them. And you can see right there the ball goes up. And so most of this video is junk. I'm only using this for this very short time frame in the middle here. So I'll pause, I'll stop the movie, and I can use a slide bar to move around. Or like I said, if you can look up here, right now I'm on frame 677, and I can move backwards or forwards, and you can see the ball moving up and down. The ball's a little bit blurry in this video. If you use a 240 frame per second iPhone, you'll get a sharp image the whole time in a video like this. But this is moving just fast enough where each photo I'm taking gets a little bit of blur the faster it's moving. And you notice it's blurrier when it's down near the bottom, because I'm moving the fastest on the way up and the way down, and I'm the slowest at the apogee. If you go back up to the apogee, you can see I get less and less blur because I'm slowing down. Plus you can see I'm not quite focused on my ruler here. I'm not sure what my resolution is either. This might be 720p. I thought this was HD, but it's HD, but it's not 1080, I don't think. And I think the iPhone is. So I'm going to go back. I'm going to back up. And I'm going to start it. I can't see it there, so I'm going to use this as my first starting point, just as the ball is starting to come out. Alright, so what we want to do next is we want to set up some movie options. And what we're going to do is you're going to use this pull down menu under options, and you'll select movie options, and it'll pop open this pane. And there's several features on here that you'll want to adjust. The first thing you always want to remember to click off on this box right here, and this sets the first point, which is going to be when the ball is just coming out of here. When I set that as my first point, that will set to your initial condition, so time will be 0 for that spot. Next, you'll want to do, if this is a slow-mo video, if you're using a standard video, you don't have to check this off. But if you're using a slow-mo video, you'll want to change the frame rate to match the frame rate of your camera that you're using. And in my case, I'm going to click this off and change it to 120 frames per second. If the video is a longer video, what you can do, rather than collecting like 5,000 data points because your movie's moving so slow, what you can do is you can skip every so often. You can skip like 10 frames at a time and move forward in chunks of time that are equal chunks in time. And this is what this allows you to do with this option. Right now it's set to just move 1 frame at a time. And you'll see when I initially select my data, I'm going to have probably 30 or 40 data points if I were to go up and down. And I only want maybe 15 or 20 for this video I'm trying to take. So I'll probably change my skipping to maybe 3 or 4 frames every 3 or 4 frames it'll skip. And you can watch it as you're selecting your data points. You'll see these numbers increment by that number you chose, whether it's 1 frame at a time, or you can skip every 4th frame, for example. And that's probably what I do, is every 4th frame. So let me show you how to do that. So here's my options, and I'm selecting movie options. And first thing I want to check off is this guy right here. It sets my time equal to 0. This is high-speed video, and so it is done at 120 frames per second. And remember, if you have standard videos, you don't have to play with that at all. And this is a pretty short time frame I'm going over, but because it's a slow-mo video, I probably want to advance maybe every 3 or 4 frames. Let me pick out 4 and see if actually let me keep it at 1. Show what that looks like. Next, what we're going to do is we're going to turn on our toolbar here, and the way you do that is you actually click on this button that I've highlighted down here. That toggles on and off your data point settings up here. And then I'm going to give you a larger view of these buttons, and I'll show you which ones that we use. The first thing you want to do is you'll want to set a frame of reference for your video. How big are things in this video, so we can calculate distances and times and calculate your speeds and accelerations from those numbers. And so you'll use this ruler measurement here. There's another one here. If you know the distance to your video, it can use that as well. And right now I could use that and pick out, I think I had it set up at 2.1 meters. But I'm going to actually use, you notice I put a meter stick in the background here, and that meter stick should be in the same frame of reference as this ball, so it should be in that same plane. If it was back 2 or 3 feet from the ball, then that meter stick that you measure out as 1 meter would actually be relatively small compared to the ball, because you've moved it back away from it. If the meter stick was way in front of the ball, the meter stick would look exceptionally large compared to the ball, and you get a perspective area for either one of those situations. As I have the meter stick set up in this video, it's taped to the beam here, the red beam, and and the ball is only maybe an inch or 2 away from the meter stick, so they're fairly closely in the same vertical plane of reference. And so I can use that meter stick as my scale, and I'll be doing that. The next thing you want to do is you'll want to choose where you want your origin for your data. And I'll be clicking on this tool right here to do that. And you'll see I can set that, I can actually tell where my starting point is. And as you can imagine, I'll probably want it where the ball starts. And I can also rotate the axis if things are a little bit crooked. Like my camera, you'll see when I set this, my camera's a little bit crooked, and you'll be able to see that. And I can adjust for that. This is also, rotating your axis is also nice. If you're, for example, having something going down a ramp, you can just rotate the axis to align with the ramp and just follow it right down the ramp. Later on, after you've collected your data, you can go back and change either of these settings, and those settings will flow right through your data, so you don't have to recollect all of your data. If you found, for example, that you had the wrong distance setting on your scale, for example. You can also, after you've got these set and you're collecting data, if those are getting in your way and you want to hide those, you can use these 2 keys right down here to hide both your axes and your ruler measurements. So let me show you how to set this up. So I'm going to toggle on my tools, and so here's my toolbar. And the first thing I'll do is I'll set my ruler. And you can see I'm going to use my meter stick here, and I'll click and hold and go right down to the bottom, and looks like I'm pretty close to the actual measurement here. And I'm at 1 meter. It automatically assumes you're going to put a meter in here, but if you had something that was 6 inches high, or for example these blocks are 8 inches wide and 8 inches tall, I could just type in an 8 and then change my units to inches. So there's my scale for my photographs here. Now what I'm going to do is I'm going to set up my axes. And so I'm going to click up on my axis tool up here. And it'll ask me where do I want to set my origin. Now normally you would think you'd want to put your origin right on your object. Alright, and that's not a bad idea to do. The only thing you'll see, sometimes the axis itself sort of clutters up your video as you're going, but remember, you can always use these tools to turn them off. I think we're in a pretty good shape though. We'll be able to see everything, and if necessary, I'll turn it off later. But you'll notice I'm a little bit crooked here with my video. You'll notice relative to my meter stick, and if I actually move these over and line it up with these lines on the wall, you can see I'm not quite aligned. I am aligned with this groove in the wall, and up here I'm off. So I'm just going to align it with the wall there. Just see if I can get this close. About right there, I'd say. Now if I move this back over, you'll see that it's running right up my ruler. I'll leave it right there, a little bit offset from the ball. But you'll notice I'm picking my zero height to be where the ball starts here. Alright, now that I've set that up, I'm ready to go to the next step. So now we're ready to collect our data. And what we're going to do is we're going to continue to use these tools. In fact, the tool we're going to use is this one right here. This is called the Add Point tool. They call these VA points. And I'm not sure what the VA stands for. You can look it up. And what we're going to do is we have the ball down here. It sets up a set of crosshairs for you. You already saw those crosshairs. I'll line it up right over the middle of the object, and what I'll do is I'll click. And when I click, it'll add a blue dot right over that point where I moved it. And if you look up at your stepping tool up here for your frames, it will step one frame at a time every time you click. Unless, of course, you told it in the movie options to move more than one frame per click. So what we'll do is we'll run a few points and see how far apart they are. And if it looks like I'm going to get way too many points, I'll go back and erase the data, and I'll go back and start over with and maybe skip every third or fourth point, something like that. As I add the points, if you look over on the data chart on the left side, you'll see those rows being filled in. If I made the video smaller, right behind here, you can see an XY axis being set up, and it will actually it'll plot those points, and they'll magically appear. By mistake, if we were to click off to the side or something and put a data point where it doesn't belong, go ahead and use the select tool, which is this white arrow, and you click on that. Then you can go click on whatever point you don't like and just hit the delete key, and you can delete it. And you can do that with multiple points if you need to. And once again, if it turns out as you're going along you see you have way too many data points when you're stepping one at a time, one frame at a time, you can change the advanced frames to a number like 4, 5, 6, 7, 8, 9, 10, whatever. Play with it a little bit and see how it works. And just one last reminder, after I've collected all my data and I filled out this table, I can actually go back and change both my scale and my ruler here, and all those changes will ripple right through my data, so I don't have to recollect my data. So let's go see how this works. So one thing to notice here is in my video, it's already added some columns of data even before I've put any data points down for my position, my x velocity, my y velocity, and there's some other things hidden under the table. Let me see if I can pull it over just so you can see. So it looks like right now it's giving me position, x velocity, y velocity. If I back up here, you'll see time. So I have time, x, y, vx, vy. That's the data it's collecting for me. So I'll just keep this table off to the side. Maybe I'll open it up a little bit so you can see all these things pulling in place. So now what I'll do, I've already set my video. I'm on frame 662 here. That's exactly where I expect the ball to start. So let me just see, stepping one at a time. I clicked on my Add Data Point tool, and I'm going to hover my crosshairs right over the object, and I'm going to click, and you'll see it added a blue dot, and the ball moved up a little bit, and I advanced one frame up here. And you can see the ball's moving pretty quick, and I'm only shooting at 120 frames per second, and so I'm getting a little bit of a blur here. If you were on an iPhone at 240 frames per second, it would be a nice clear picture with the ball. So it's a better camera than I'm using on this. And so I have to assume, if I'm looking at this, the ball is moving up, and so this top part of it is where the ball actually is, and I'd click my next data point there. And I just continue over and over again to estimate where that center of that ball is and just follow it up. Now, like I said, I really only want maybe 15 or 20 total data points. And as you see, I'm getting quite a few data points here, and I'll just do it sort of quickly. And this is going to give me way too many data points. I'm not even to the apogee yet, and I'd like to trace this thing all the way up and down. And I'm already at 15 data points. And so this is too many data points for me. So what I'm going to do, let me clear my data here. And I'll back up to the beginning of my video right there. And what I'll do is I'll go with every fourth point to skip. Let me go with every fifth point. All right, so there's our first, our second, and if you watch the counter up above, you're going to see it's going every fifth data point now. It'll skip 5 frames at a time here. So there's our third data point, fourth, fifth, sixth, seventh, eighth, ninth, and here's our, looks like this should be our apogee somewhere in here. Now we're moving back down again. And you can see the bigger your video is, the more precision you're going to have to track this thing. And you need a high contrast background against your object. So I have this bright red beam and this yellow ball that I'm tracking, easy to track. If you had black on black or white on white, forget it. And if you don't have a relatively decent sized object, that's going to cause a problem as well. So that's our data. And here I have 19 points. I wanted 20 points, so there I am, right in the ballpark. So I'm done with the data collection. And if you look, let me just slide this out of the way. Here's all of my data I just collected, and underneath you can see some motion graphs that were created. I'll slide that out of the way. And you can see a position versus time motion graph. So let's just see how we can adjust these graphs so we can see everything that we'd like to see in a nice view. I'm sort of lucky here because I'm working on a 24-inch monitor that's a widescreen monitor, which allows me a lot of flexibility to see things nice and large. And then you can do a screenshot and save it and include it in a report if you want. You already saw me hide the video. The video is actually sitting behind these graphs, and if I were to drag these graphs over a little bit, you'd see the video if you ever wanted to bring it back up, and if you saw something weird with the data, you could go back to your video and see if there was an error, maybe with one of your data points. So, and you can also click on the dragging bars here to resize any part of these windows that you'd like pretty easily. You can also do some adjustments on the scales by dragging along as well. I'll show you how to do that in a second. But you can also do that from the menus up above. Under options, I can adjust the scales on the graphs, or I can right click to access those options as well. And probably more importantly on this, I'm missing some graphs here. So I'd really like to add a velocity versus time graph, and you can see I have velocity data here, so it'll be easy to add that. And we'll just use the option up here to insert a new graph from existing data columns, our velocity data. But the bigger problem is I'm missing data for acceleration, and it'd really be nice if I could use some mathematics to figure out from my velocity what my acceleration is. For example, if I could use a slope from of a secant between adjacent points here, I could do that. Or in calculus, we do something called taking the derivative to do that, and which is what I'll use. So let me show you how to do that, and it's pretty easy. So if you look here, I'll just show you where my hiding video is. It's right underneath here. So if I ever needed to pull that up and play with it again, I could do that. And so what I'm going to do here for my graphs, let me just pull in a little bit of extra room just so you can see some new data I'm going to pull in here in a moment. But I can resize these graphs all I'd like. But the first thing I'd like to do is I'd like to insert an additional graph. And if I just click on it, it automatically assumes that I'm going to look at my data that I don't have yet. And it's giving my velocity data. And you'll notice here, and I can resize my windows to add these in. So here's my position versus time graph. So now I have a velocity versus time graph. And I'll leave some space down below for acceleration versus time graph. And you can see I just added in 3 VA points by mistake because I still have these on over here. So I'm going to delete those out. Whoops. 1, 2. Now where's the other one? I think that was the only one I had in there. And I'm going to turn these off so I don't do that by mistake again. So don't forget to turn off your tools, and that'll protect me from messing that up again. So I'll just click on these ones to bring them back to the forefront. Now you'll notice I'm getting a Y position in blue versus time, and my X position is not moving. Well, of course it's not moving. This is straight up and down as best I could do. And so those things are really irrelevant data. So I really don't care about that. So it'd be nice just to ignore that. So if I can, there's a couple ways you can do this. You can actually delete these extra columns in here. And I just clicked on the column, and I can right click and I can delete it. The other thing you can do is you can go in and you can actually adjust your graph settings here. If I click on my titles here, I can actually look at what I want to display on this. And if I really only want to display the Y, I click on Y, and it ignores the X data. When I picked out the velocity graph, it automatically assumed I wanted the Y velocity only. But you'll notice I can plot multiple things on a graph. I can plot my position and velocity on the same graph if I'd like. And the question is, what would it do for the scale? You could set up a dual scale on both sides if you wanted to, but that gets a little bit cluttered. I like mine stacked. So this one's already set up for Y velocity. And like I said, I really don't care about the X data, so I might as well just get rid of this. So I'm just going to delete that column. And you notice it deleted the X velocity column. The Y velocity column is actually calculated from the Y data. And so this is a calculated column. So if I delete the source column, it'll delete the one after it as well. It automatically calculated my times on my video here using our frames. And so we've got it was only up in the air, up and down for about 0.75 seconds, and it went not even a meter. It went about 75 centimeters up. In fact, I think I can click on this data. In fact, you see I clicked on the data, and it's highlighting for me my apogees at about 74 centimeters high. And I can use a tool up here in my toolbar to do that as well. There's a point tool up here. I can examine any point, and I can take a look at that point, for example. All right, so I'll turn that off. I don't really need that. So I would like to, however, get one more graph. So you saw how I added my first graph based on some data I already had in my table here, and I used the insert graph tool. And what I'm going to do now is I'm going to have to add, I don't have any acceleration data, so I'm going to need to generate some acceleration data, and I'm going to make myself a little bit more room for this acceleration versus time graph. I'm going to try to align my times so they match nicely. And so to add in a new column so I can graph some new data, what I'm going to do is I'm going to go under Data, and I can actually add a column. I can put a manual column in. I can type in the data myself. But what I'd like to do is insert a calculated column. And it gives me this dialog box. And I can name the column. Well, if you look at the names we have up here, I've got Y velocity. So this I'm going to call Y acceleration. I'll just shorten that a little bit. And it gives you the opportunity for a short name. I'll do YACC just for a shorter name. You can put down the units. It's meters per second if you'd like, or you can use, if you click downward here, I want a superscript 2. There's my meters per second squared. And it's asking you which set of data you want to add this to. Now you'll notice all these are boxed under the same data here. This is my video analysis data. If I had another sensor's data in here as well, perhaps at the same data, maybe I use sonar to collect data at the same time I was using video. So I could have the sonar data sitting grouped together, and I could have the video analysis grouped together, and it would color code them separately. But I'd like to go have these new data for acceleration put under the video analysis, so I'll keep that. And then it asks me to set up a formula for it. And I'm going to use a function. I'm going to take my velocity, and I'm going to, in calculus, to get my graph below, it's called taking a derivative, the first derivative. And so I'm going to take the first derivative of my velocity data. So the function I'm going to use is under calculus. And you can see you can do all sorts of different things here. There's natural logs, there's a ton of different things you can do. I'm going to go into the calculus functions, and I'm going to take the derivative. And you can see I've got all sorts of calculus functions I can use. I can use derivatives, derivative with a time shift. I can use an integral, which calculates areas. I can use a second derivative, which means I could take my second derivative of the top graph to jump down to the graph 2 below it. But what I'm going to do is I'm going to just take the derivative, and then it's asking me in parentheses, well, what do you want to take the derivative of? Well, I'd like to take the derivative of, if I can get my cursor back in here, my y velocity data. And so that's actually a column. I'm going to stick a column in there, and I'm going to grab my y velocity. So what I'm doing is I'm taking the derivative of my y velocity, and I'm going to call it this new column. All right, and there's a parameters option you can put in here for time and things like that. So I'm going to hit done, and here's my acceleration data. If I double click into this, I can go back into my labels here, and I should be able to change colors. So for example, maybe I want to do, I'll use 3 different colors. Yeah, we'll keep that. We'll keep this one green. And I'm going to change my velocity. We'll change that to, I'll change that to red. Okay, so my position is going to be the blue graph, velocity is the red graph, and my acceleration is the green graph. Well, where's my acceleration going to come from? Well, now I can go to insert again, graph, and it's going to pick up my missing one I haven't graphed yet automatically for me. And there's my graph of acceleration data. Now remember, if you look at this data, how good does it look compared to the other data is one question you want to ask yourself. And we'd expect here that it's going to be uniform acceleration. But you got to remember, the actual data that we're using here that we're measuring using the video is actually our position versus time. So the data we have in the velocity graph is calculated based on this top graph, and then our acceleration is calculated based on this one we calculated from before. So every time you do another calculation on your data, it gets further and further from the truth. But if we look at the middle portion of this data, it looks like we're getting, somewhat constant acceleration. And I think I know how they're doing their calculus here. They're actually probably using some time average value, so it's probably looking back into 2 or 3 data points. It's called a moving average, and that's why it's picking up these slopes going up and down. And if I were to adjust or use my own formula, better yet, I might find it's a better representation. The other thing we have an issue with, especially when we get to the slow speeds and the dots are close together, when we're plotting data, how good were we at pointing out on our cursor and clicking in our VA data points when we were on the video? And we might have some error in there as well. So I would probably sort of chalk our endpoints up to the methodology they use to take the derivative, and I'd sort of look in the center here, and I see, yeah, I've got constant acceleration, and if it's here in the center, it should have been on the outsides as well, because it's free falling the whole time, and this is just a matter of the methodology they use to calculate the derivative using some sort of moving average or something. So now, do I like the scales that we see here? The time scale, it automatically fit the time scale for us. That's not a problem. But you'll notice what I can do if I don't like the scales. There's a couple of ways to do it. I can do it visually by moving my cursor around until I get this funky shape on my cursor, and it'll stretch out the scale. If you come in the middle here, it'll shift the whole scale up or down if I'd like, which I don't really want to do. I'll just leave that right at 0, 0. And then I can, if I go a little bit lower, it'll pull the scale down this way to stretch it out as well. But I like my position scale, my velocity scale. My acceleration scale, I'd really like to probably see from 0 to -10, because I think this is distorting my view a little bit by starting at -6. And so what I'll do is, once again, I can just take this and grab it to stretch this out. And really I want to see the 0 point here. So I mean, my 0 is up here someplace. But rather than doing all this stretching stuff, let me go in. I'm going to right click on this graph, and I'm going to go under graph options, and I'm going to go under axes options. And you'll notice I can put labels on my axes if I want to relabel my axes and so on and so forth. But right now what I'm going to do is I'm going to change my scaling on my acceleration axis. My time axis, which is my x-axis down here, is time. You can see there's time. I'm going to leave that scaled, auto-scaled, because it's already matching my graphs up above. So I'm going to focus on my y-axis. And instead of auto-scaling, I'm going to pick my own numbers. And I want to start it up at 0, and I want to go down to maybe minus, I think my lowest number is maybe around -11. Maybe I'll go down a little bit more. Let me go back into that again. Right click. I actually right clicked, hit graph options, maybe go down to -12 or so. Done. And now you can see my 0's up here. And you can see once I show my 0 in here, and I expect things to be down at the -10 meters per second squared range, you can see my data looks better already just by adjusting the scale so I can see what I'm supposed to be seeing. I still have these parts up here on the both ends, which I think are just the way they're calculating the derivative, which are messing those up. But you could try some different options on that. But those are my graphs. So all there is left to do now is, now that we've got some nice looking graphs, we could actually do some data analysis. And so now that we've collected our data and created our graphs that we'd like to take a look at, we can now analyze these graphs and see what interesting information we can pull out for our lab report to justify whatever we're trying to show for our hypotheses. And what we'll be using is this set of tools right up here. You can also access these from the Analyze drop-down menu. And what we can do is, and this is just a blow up of those icons so you can just see them a little bit better. We can look at individual point values if you'd like to, using the first tool here. We can also add a line of best fit if we'd like to, and that's the line of best fit you see over here. And you notice that's R equals, they're giving you a regression line is what they're telling you. How do you run a regression on curved data? That's this last icon to the right. And you can see on our first graph we've got a big curve, and if we happen to know what the shape of that curve should be from a theory, then we can actually successfully try to fit it with something that matches. And then we have some slope tools. We've got these, you'll see how this tool can be used to just look at slopes at any point on our curves. And then we can also calculate areas under the curve. And that's the tool over here. And areas, by the way, that's called an integral. And slope, calculating a slope is from calculus is called a derivative. Finally, they do have a statistics tool, and that just gives you an overall summary of what your data looks like on any particular graph. Not very useful, to tell you the truth. So let's go ahead and try out some of these tools and see how they work. So back to our 3 graphs that we created from our data. And just remember that our first graph up here is position versus time, and that's the graph that we're taking from our actual data directly. All these other the red and the green data from our velocity and acceleration are calculated based on those, and so we might be getting calculation errors that are flowing through as we go on down each level here. And so our best data that we have is actually on our top graph. Just keep that in mind as we do our calculations and our analysis. So let's just take a look at these different tools. Let me just show you this stat tool first. This just shows you, and I didn't have any particular graph selected, and so it just picked them all up for me. So it just shows us here for video the velocity, for example. It shows us our min and max values. It shows us a mean and median, standard deviation, how many samples we have, and our change in our velocity over this entire range. So whoop-de-doo, I can read that off the graph pretty much. So if you needed that, that's what you can do. If you want to get rid of these, you can just X out the dialog boxes, and they'll disappear for you. Secondly, if we wanted to pick out any particular point, I can use this tool here, the examine tool, and it will move me along here through my graph, and I can go down from graph to graph, and it will just show me in the little dialog box what graph we're going. It'll show you on the table where you are in your graph as well. And I can just float over every one of the graphs and just move along just to see my data. In fact, for my acceleration graph, that's probably the best tool to use, because we expect this graph, because if this is constant acceleration free fall, this to be a level graph. Now we already know, I already pointed out that we have this error in the beginning and at the end, and I'm guessing that's from the methodology they're using to calculate the derivative. They're using some sort of moving time average, which is throwing off our data. But if you look in the middle set of data, then we can sort of walk along that data and see what that data gives us. In fact, what we can do is, so I can click and hold, and I can select all this data at once. And I might be able to do stats just on that set of data. Let me see if that works. Yeah, so I clicked the stats just on this set of data. So I highlighted a set of data. I was just holding down the left mouse key, click and hold, and let go after I highlighted the data. And for this set of data, for the acceleration data, it ranges between negative 10.68 meters per second squared and negative 9.47 meters per second squared, and it gives you the times those happen. And it gives us our average here. So our average acceleration we're seeing over that time frame, based on this point-to-point calculation it was doing, is about negative 10.2 meters per second squared. Not far from the value we had hoped to get, which is negative 9.8. So you're about 4% above what you'd expect. Can't complain. And so there's our statistics tool, just to get me an average value if I wanted that. I could probably also, on this data, if you want me to, I don't know, it's not worth it here to even try to plot a line, because it shouldn't have a slope, and we know this data is bouncing around a little bit, but we can see it is the shape that we'd like to see in the middle at least. So I'm just going to leave that alone. On the graph above, though, and I'm going to turn off these tracking tools here. On the graph above, what would we like to do? Well, a couple things we can do. It'd be nice to fit a line of best fit through here, because we know the slope of that line should give us our acceleration. So what I can do is I can select the entire set of data. If I just wanted to pick a portion of the data, I can click and hold and select just the portion of data that I'd like. But on this graph, I think I can just click on the whole graph. I can do that. If I just click on the graph as a whole, you can see this graph is highlighted. Not very well, but it's highlighted. And it'll let me probably do the line of best fit on all the data at once if I do that. So I'm using the line of best fit tool, which is right here. And it drew a line of best fit. And you can see I'm running, fairly well through the middle of my data. It doesn't look like it's trending one way or the other relative to this line. It's sort of back and forth along this line, which gives me a good feel. You can see my first data point is low. My last data point is high, which is causing this action to happen down below here for my acceleration graph. Maybe you could leave out those 2 points, but they probably offset each other in any case. Or would they bend a line a little bit? We can try it again and see what happens. But you can see our slope of this is getting us negative 9.98 meters per second squared, which is a pretty good estimate for our gravitational acceleration. So that's not a bad calculation that we have going there. Let me try leaving these two data points, the endpoint data points, out. Let me try another line of best fit right here. So I can run multiple lines of best fit on the same data if I'd like. So here's another line of best fit. And this line of best fit for this middle set of data, ignoring those two endpoints, which are sort of skewed strangely, is giving us about negative 10.2 meters per second squared. Of course, I should have stuck with the first set of data because it matches my data better. But now that I've picked this out, if you delete this data, I don't know, that's fudging your data at this point. And so you might be obligated to keep that data in and try to explain why there's a difference between the two. Now, in terms of printing out your results, what I would do is I would just align these out of the way someplace, and you can see it's pointing to the different lines, even though in this case my lines are overlapping. Let me get rid of the second one I put up here. So this is showing my line of best fit. And you can actually take a screenshot of this and include it in a report, or you can actually print this page. And you'll have to set up your page settings so it prints in landscape mode. But I tend to like to take screen captures and cut and paste them in so I can modify them the way I like. So let's do a curve of best fit on here, if you want to call it that. What's really called is a regression. And we're doing a regression based on a theory that this should be a second-degree polynomial. And you should be able to explain why that's the case. So I'll just go ahead. I'm already clicked on my graph. If I just click on the curve fit tool, now I can select what type of function I'd like to use. And you can see it gives me a whole range of functions, from a proportional, linear, quadratic, cubic, you name it. And we've got probably a couple dozen functions to choose from here. Lots of different useful functions to use. And of course, ours is sitting right here. We have a quadratic that we're fitting to, a second-degree polynomial. And because we set our time to 0, we don't have to do a time offset. If you forgot to set your time to 0, you could click on the time offset, and it would take your first point that you selected in your grouping of data to be your time 0. And then I'm going to do an automatic fit. And you could actually create in your data table over here a calculated column to see, and you could line them up side by side. Maybe I'll do that just to see what it looks like. And I won't plot the column, but I will show the curve fit. Well, let's go ahead and plot the column too. And so what I'll do when I do this, select these options, the show curve fit is going to show the curve fit that I'm trying to fit in my data. If I plot this other data, it'll show my model data versus my actual data that I actually plotted on my video data. So if I go ahead and do a try fit here, that shows the curve that it's fitting, and it looks like it's running through things pretty well. And this number right here, some of you may have done regressions before and used a value called an R-squared value, which is a correlation coefficient. This provides a different type of piece of information to show you how well things fit. And RMSE stands for root mean square error. And what it is the average distance you are from your curve of best fit in terms of its height difference from the curve. So if you're a bit above, you'll have so many units above, a little bit below, so many units below. And the units will be in our y-axis units here, which are in meters. And so our average error is about 3.3 millimeters. And you notice it's a square error, so that takes away signs from this. And then we take the square root again. That's what the root means. And so it doesn't matter if it's positive or negative. Those won't cancel each other out. It'll give us the average value above or below that we're getting here, which is about 3.3 millimeters out of about a meter. And so it's a fairly small error overall, seeing as we're going about 800 millimeters in this range here. The other things to look at here are what your coefficients are up front. Remember, we're trying to fit a curve based on our constant acceleration equations for the position versus time. And we have our coefficients are, for our quadratic term, are 1/2 times your acceleration, and our b is your initial velocity, and our c is our initial position. And so it looks like this term A, which is 1/2 our acceleration. So if we take this number and double it, we get 10.28 meters per second squared. That's not far off from our actual 9.8 that we're looking for. So we're about 4 or 5% high. If I hit OK, it'll go ahead and plug that in. And it's also on top, it's graphing my curve fit right here. And it's graphing that right on top in these square shapes here. The squares that you see, let me see if I can zoom in a little bit on this. You can see a hollow square here that's actually following this black curve that I've put in here. And then my actual data, so you can see how high above or below each data point is. And here I'm pretty much in the center. Here my data, my real data is a little bit below this model I'm fitting into here. I'm a little bit below, a little bit below, tiny bit below, tiny bit below, dead on, dead on, dead on, tiny bit high, bit high, bit high, bit high, dead on, tiny bit low, tiny bit low, tiny bit low. So overall, we're pretty close to our data. And like I said, this root mean square error tells us that we're on our 800 millimeter height that we've gone through here, where our average error is about 3.3 millimeters, which I would say is fairly small overall. So, and then each one of these, you could interpret each one of these coefficients. Now remember, A for this is a motion equation, and motion equation number 5, that's 1/2 our acceleration, and you would write out a statement about that and tell what that means. The second is our initial velocity, and so that gives us what the initial velocity of our ball was. We did not know that before, but we can look on our velocity graph to see that as well. And if we look at our velocity graph, our line of best fit, it's on this one was tracking at about 3.7 meters per second. I'm just going to save real quick here. I'll warn you right now, you better save often in Logger Pro, because I actually had to recreate these graphs a moment ago because it crashed and it just does not have any type of feature to pull up your data that you're missing unless you save yourself. So be forewarned. So we've used a curve fit, linear fit, and regression, just normal statistics for a set of data. Let's go ahead and try out some areas. We know the area is really meaningless on our position versus time. Maybe I'll stick this underneath. But area for these two graphs is more important. And so let's just take, I don't know, you tell me. You should be able to calculate some areas and tell me what they mean. For example, if we calculate the area from here to here, I'll just select those half of the data points and just click on my area tool. That's the area I just calculated under my actual data here. And it told me that area is such and such, 0.7136 seconds times meters per second, which is meters. You should be able to tell me what that means and relate it to what happened up in this graph up above. And so on and so forth. I could take the area over this side. I could try taking some areas down below, but use that wisely and show me that you know what it means and interpret the data appropriately. And that's a good summary of our tools that you can use, and you should show me how these are used and how to pull out that important information out of there and compare the different graphs and tell you what they show.